In this example, we're going to evaluate this definite integral, and it looks like we have the integral from the natural log of 2 to the natural log of 3, and our integrand here is e to the negative 2x, and of course that's with respect to x. So I suspect that since we have e right here as a base, and we have some natural log values for our limits of integration, this problem should actually come out pretty nicely. So if you'd like, go ahead and pause the video and give it a go, and then come on back, we'll work it together. Okay, so looking at this integral right here, it seems like our best bet is going to be a U-substitution, since the exponent here for this e is actually kind of a function in and of itself, so we have negative 2x. So let's make that u value a negative 2x, which means when we differentiate both sides, we'll have du equals negative 2 dx. And then, of course, solving for that dx, we'll divide both sides by that negative 2, and we'll have du over negative 2. Okay, so that's that first little part. Also, what we need to do is, because these limits of integration that we have here are based in x, since we're using a U-substitution and changing these variables, we also need to change these limits of integration. So since we're using u equals negative 2x, we need to change this so x is the natural log of 2 and x is the natural log of 3, and we need to go ahead and just change these. Okay, so we'll plug this natural log of 2 into this x, so we'll have negative 2 times the natural log of 2, and then for this one we'll have negative 2 times the natural log of 3. And we could kind of adjust these a little bit if you want. We could use the properties of logs, and then we could say this is the natural log of 2 to the power of negative 2, and the natural log of 3 to the power of negative 2. And even taking it one step further, well, what is 2 to the power of negative 2? Well, it'll be 1/4. So we could say that, and then the natural log of, okay, so what's the power 3 to the negative 2? Well, that's 1/9. So we could use these values. Okay, that's kind of cleaned up a little bit. So let's go ahead and do that, and then rewrite our integral now in terms of u. So our integral will be from the natural log of 1/4 to the natural log of 1/9, and that's going to be e to the u, and then this dx ended up being du over negative 2. Okay, so that's kind of where we are right now. We'll go ahead and block this off as well so that doesn't get in our way. Okay, so this negative 2 in the denominator, we could bring that out front and use that as a constant out there. So we have the natural log of 1/4 to the natural log of 1/9, e to the u du. Okay, and that is a very simple integral, because the integral of e to the u is just, well, yeah, e to the u. And so our limits of integration then are the natural log of 1/4 to the natural log of 1/9. So let's just go ahead and plug these in and see what we have. So 1/2 times, and we have e to the natural log of 1/9 minus e to the natural log of 1/4. So that'll be a negative 1/2 times. And what happens here is when we have e to a natural log, those kind of are inverses, so they cancel each other out, and this 1/9 becomes a real 1/9. And similarly, it'll happen here, and we'll have minus 1/4. And now it's just the numeric bit of this, so we can get common denominators here. It looks like between 9 and 4, let's see, 36, so we'd have 4 over 36 minus 9 over 36. Should be negative 1/2 times, what, negative 5 over 36. And the two negatives will cancel, and we'll end up with 5 over 72 for that integral when we evaluate him. Okay, so 5 over 72. So let's go ahead and recap. We'll just kind of rehash what we just did. So we saw that a U-substitution was going to be a great way to do this. So we went ahead and did our U-substitution, but the limits of integration also need to change because of this U-substitution. So we did that here as well. And once we did that, then this actually ended up being quite a nice integral. So the integral of e to the u was e to the u. And then it was just a whole lot of steps of evaluation with the numeric pieces. But 5/72 is what you'll get for that answer.